Good morning, all. Thank you for attending our webinar this month. Today's topic is Power Monitoring and Management Solutions. We're going to focus on factory and building automation applications, but it can be used for other applications as well. We'll show a few slides at the end of the presentation for some additional applications which our power monitoring and management solutions can be used. Here's our agenda for today. First, we'll go over monitoring power for factory and buildings. Secondly, we'll go over how to select the correct power meter and monitoring solution products. And then we'll talk about how to set up a power monitoring system. And we'll finally talk about integration with SCADA software and data logging applications. ICP-DOS was established in 1993. Our headquarters is in Hsinchu, Taiwan, and ICP-DOS USA was launched in 2001 to support the North and South American markets. Our products are ISO 9001 certified. We're a Microsoft embedded partner, and our products are RoHS compliant. Okay, first we'll go over energy management solutions. Here's a picture of two of our power meters. We'll go over in more detail in a few slides, but these power meters will allow for real-time monitoring of circuits for both power consumption, and voltage and current, as well as many other measurements. These measurements can be used to help reduce and monitor energy consumption and reduce the cost. They have relay outputs to control as well. With the power meters and touchscreen PLCs provided by ICP-DOS, users can simply get access to the energy consumption readings. Here's an overview of our smart power meters. We have several different models. At the top are some pictures of our PM3000 series. The PM3000 series, the part number breakdown is on the left. It's a basic overview. The PM3033 is a single phase power meter, or I'm sorry, a single three-phase power meter for one circuit. The PM3133 is also a one-phase power meter. The PM3122 and 3114 are used for single-phase power. And the big one at the bottom is our PM4324. This can be used for either three-phase 8 circuits or 24 single-phase circuits. We provide different models with RS485, Ethernet, and CAN open communication. I'll show you the model selection shortly. And we support Modbus RTU, Modbus TCP, and CAN open protocols. Let's see, some models support built-in relays for control. And we have better than 0.05% power factor accuracy. Okay, first we'll go over our single-phase power meters. These are used for single-phase circuits. The model shown is the PM3112. This is a Modbus RTU version. We have clip-on CTs that come with the modules. Let's see, we have a few models which you can also supply your own, but this model in particular comes with two clip-on CTs. It supports the measurement types shown and features true RMS power measurement. This can be used for single-phase 2-wire or single-phase 4-wire applications. And we have various models which go up to 200 amp CT ratio. The maximum voltage for this model is 300 volts. And we have models which support RS485 Ethernet or CAN bus, with CAN open being the protocol that the CAN bus module supports. And this model has two power relay outputs, Form A, and this one doesn't support PoE, but we have others that do. Here's our one-channel, three-phase power meter. This one supports also true RMS power. Let's see, works for three-phase four-wire solutions, three-phase three-wire solutions, single-phase three-wire solutions, and single-phase two-wire solutions. And this one we have models for up to 200 amps. And this one, the voltage measurement can be up to 500 volts. So it works great for 480 volt applications. This particular model, the Dash 100, supports RS-485 communication, which is Modbus RTU. This slide shows the various part number breakdown for ordering. PM3133 and PM3122, or I'm sorry, 3112 are the model, and then the rest of the part number is as shown, where the CT size is the next boxes, or three boxes. The 100, 160, 240, and 360 represent the hole size or diameter. Note the maximum current just to the right of that. So for the CT where it's 100, it would be a 10 millimeter diameter hole up to 60 amps max. You must take into account the CT hole size as well as the maximum amperage when choosing the correct power meter. And we have models which allow you to provide a second CT or a secondary CT. That's shown by the P as in Peter at or in that box with the green box. And finally, at the end, determines the communication type that you want from the power meter. So if you want Modbus RTU, you choose the RS-485 version, which would just have no extra letters after the 100, 160, 240, or 360p. If you want a can open solution, you want to have CPS at the end, shown at the bottom right corner, and Modbus TCP version would have MTCP at the end. Be careful to order the correct end designation, otherwise you'll get the wrong model with the wrong type of port and communication in different protocol than you want. So please be careful, and if you need help choosing the part, please give us a call. Next, this is our PM4324. This is a multi-channel power meter. It supports up to 8 three-phase circuits or 24 single-phase circuits in one module. These easily fit into existing panel boards, and mounting can be DIN rail. We do have models that support Modbus RTU, Modbus TCP, or can open as well for this series. This is great for apartment buildings, building automation, and large complexes where everything's wired to a central control room. This has features of true RMS power. It's designed for various wire types, including single-phase 2-wire and single-phase 4-wire. It also supports three-phase wiring too. Current measurements can be up to 200 amps with different CT ratios, so please choose the correct model based on the CT ratio. That will be shown in the next slide. Let's see, we have versions which support RS-485, Ethernet, and CAN bus, so we'll show you how to choose those. Here's the part number breakdown for the PM4324 series. Again, the orange letters, they correspond to the CT size. Note the maximum amperage to the right of it. Let's see, the P, again, stands for a secondary voltage transformer if you need one. And communication type is either RS-485, can open, or Modbus TCP. We do have, Rogowski coil versions for even higher amperes than 400 amps. So if you do need help with those, we can help you with those as well. This is your basic application. So you note the power meters at the bottom. In this case, they're PM2133, which is the older version. It should be PM3133 now. The TGW converts the communication and bridges the gap to the host PC, which either displays or logs the um, voltage and current values, or the power meter variables, and displays them. Or you can display them using something like our touchpad, using just simple Modbus TCP, which we have versions of our power meters which can communicate that. Here's one step further. In this slide, we are adding our industrial multi-power meter display. We have a PMC module, which is designed to read data from multiple power meters. So if, for instance, you had like a large number of power meters, that's when you'd want to use a power meter concentrator or a PMD series, either PMC or PMD. You can use those to display and relieve the data logging capabilities of the PC into multiple PMC or PMD modules to lessen the burden of the PC, so it can log faster and also keep its own log. So again, in this slide, the power meters are to the right, either PM3133 or PM4324, and you could have multiple ones of those connected to the power meter concentrator shown in the middle, and then from there, the power meter concentrators pass the data to the Modbus TCP PC. This is our basic power meter concentrator. This has the features shown to the right. This is configured using a web browser, so they don't require any additional software. This one can read and record and share data for up to 24 power meter circuits. Let's see, it supports both Modbus RTU and Modbus TCP versions of the power meters, so you must choose the appropriate version, and the maximum number of channels is shown to the right. This can display real-time or historical data and provides data statistics like averages. And the data is also stored and logged onto a micro SD card as a backup to your SCADA or as a standalone system. So this would be great for like standalone, like apartment complexes where maybe somebody monitors it once a month to check power consumption, make sure no one used too much electricity or can bill at the approximate rate. Here's a 3G version of our power meter concentrator. This can pass data wirelessly through a 3G network like AT&T to like a base station offsite. And this is, again, configured using the web browser and has pretty much the same features as the standard power meter concentrator shown previously. And note this one does support IoT Star to the cloud connection. Here's our power meter concentrator with the display. This one has a 7-inch display. We also have a 10-inch version. This supports communication from power meters by Modbus TCP and Modbus RTU versions. This is also configured using a web browser. And through the web browser configuration, you set the model number of the power meter and the communication type that you want to set for each one, so you can monitor and note which circuit you're monitoring with each channel. This is great for like apartment complexes, shopping malls, and whatnot, where you have multiple circuits and you want to identify each circuit and allow either operators or maintenance people to to see the current statuses, and also you can display visual alarms, like say if current draw goes over a certain limit, or if the power consumption for a certain circuit goes over a certain amount. This supports up to 24 ICP-DOS power meters and up to 8 Modbus I/O modules for triggering external alarms or creating extra logic. This displays real-time or historical data, and you can also view the data remotely through a web browser if you had a Ethernet connection to the power meter display. Using if-then-else logic, you can create load management and monitoring parameters to trigger alarms or notifications. Here's our breakdown of our two models. Basically, we have a 7-inch and a 10.4-inch. Both support touch screens, and these screens shown here are built in, so you can use these as a template to display and monitor using the PMD. Here's a close-up of one of the screens where you can again view real-time or historical data just by touching the touchscreen or through a web browser. You can view the exact same information. And this would be real-time or historical data with averages. Using the PMC or PMD, you can also share data through a phone through a web browser. So if you have a mobile device like a cell phone or a tablet connected by Wi-Fi, you can read the data or view the data through the cell phone using the web browser. And if you have questions about compatibility, we can answer those for you. The browsers must be of certain type and must have the ability to display the data in HTML5 format. Here's an overview of the energy management solution. A note at the bottom are the RS-485 or Ethernet power meters. You can also connect I/O modules to trigger alarms, and our DL series to read temperature and humidity and display those data or save those data in the power meter concentrator or power meter displays. And then from there, using Ethernet communication, or we have a cellular version as well, which can pass the data to the management level, where you can use SCADA to share the data. You can use SQL to save to a database, or you can view the data remotely using a web browser. Oh, and note also that the PMCs and PMD are also data loggers, so if connection to like the remote server or remote SCADA system is lost, the data can be retrieved from the SD card in the power meter concentrators. That's one additional benefit. Here's just an application overview of how they'd be used in a factory automation application. So there's individual power meters at the bottom at various locations along the conveyor belts or manufacturing floor. They're keeping current values and monitoring the power usage. The power meter concentrators and power meter display allow for local access to the data and a local data log. Then the data is shared via Ethernet to the control room. Here's a building automation application. In this picture, it shows multiple circuits from different buildings, different floors, different units, all being passed to the power meter concentrator or power meter display. And that data is stored both locally within the power meter concentrators and then also passed to through the Ethernet to remote sites or to management for billing and monitoring purposes. Here's a retail mall application. Again, pretty much same structure. Individual power meters pass the data from the power meters to the power meter concentrator or power meter display to the PC to monitor and log the data. Note that you can use the power meters directly without the power meter concentrator or power meter display if you don't want local data storage, or if the PC is close enough or the system is small enough. Power meter concentrator are heavily suggested for large numbers of circuits. Here's a campus/university application. In this picture, multiple power meters are keeping track of power consumption and power usage throughout the campus and passing data to the central control room. Indusoft is our SCADA solution, which we recommend for energy management systems. There's many different templates you can use, and it's expandable to allow for remote and local data logging application and control applications. Let's see. If you have any questions, please feel free to ask them now, or you can contact us via telephone at the number shown, through our website, or via email. Also follow us on Facebook, Twitter. We have a YouTube channel. Next month we'll have another webinar, probably around the middle of the month due to the Christmas holiday. Thank you for attending, and we'll see you next time.